Tilly earns P dollars for every W hours of work. Which expression represents the amount of money in dollars that Tilly earns for 39 W hours of work? Sometimes when variables are put in, it can make it harder to see what's going on. I like to, in these cases, put in real numbers to confirm what I'm thinking the answer is. So I'm going to show you both ways. So if she's earning P dollars every 3 hours, this is proportional. This is a direct relationship here. So if the number of hours goes up, the amount of money that she earns goes up, right? If I work for $15 for 1 hour, then if I work for 2 hours, I make more money. I earn the same rate per hour. So that P is not changing, but the amount of money I'm going to get is going up. So looking at these real numbers, let's say this is what Tilly is earning. Let's see, she's earning $15, that's our P, for every 1 hour of work, that's our W. If we multiplied this by 39 and said she worked 39 times as long, or 39 hours, how would we find out how much money she made? Well, we'd say we'd multiply this by 39, right? 39 times as long, she earns 39 times as much money. So looking at our answers over here, which one of these represents that? That we took that P per hour and we multiplied it by 39. That would be A, 39 times P. None of the others represent this. Here saying it's divided by 39? No. Adding $39, losing $39? No. She earns 39 times as much. It is 39P. For a training program, Juan rides his bike at an average rate of 5.7 minutes per mile. Which function M models the number of minutes it will take Juan to ride X miles at this rate? So I like to look at it. So it's 5.7 minutes for every 1 mile. So if I asked you, how long would it take Juan to ride 3 miles? I would say, okay, I'm multiplying this side by 3, right? Multiplying that by 3. Get our 3 miles, and that means we would need to multiply this by 3, 5.7 minutes. It's 3 times the distance. It's going to take 3 times the amount of time. So that's with a real number, 3. What if I didn't know the number? What if I said it's X? It's the same thing. It's X many miles. It's X number of times longer. So it's X number of times longer in time as well. That is represented here as D, 5.7 times X. None of these others would apply. In the first one, the number of miles divided by 5.7. No, you're not relating that at all. Adding 5.7, subtracting 5.7. No. This relationship, 5.7 times X, because it is 5.7 minutes for each mile. So we multiply by the number of miles to get how many minutes it took Juan. Number 3, 3x equals 12, negative 3x plus y equals negative 6. The solution to the given system of equations is x, y. What is the value of y? So that is an elaborate, slightly awkward way of saying, find the solution to this system of equations. Now, when you have a system of equations, the 2 ways that are most common would be to solve them would be elimination or substitution. Here, when I'm looking at these, I have a 3x equals 12, and then a negative 3x plus y equals negative 6. Right off the bat, I'm thinking elimination because I have 2 terms here that are going to cancel out. Elimination, if you remember, is where we try to get 2 terms to be opposites of each other. One is positive, one is negative, but they otherwise match, so that we can add the equations together and those terms will cancel out and we are left with a single variable. And they've done that work for us. Again, we have a 3x and a negative 3x. They're going to cancel out. So I'm definitely going to go with elimination. So if I add these equations together, 3x and negative 3x, whoop, they're gone. I just have that single y is left because there's nothing to add it to in that top equation. And then when I add these together, 12 plus a negative 6 is positive 6. That's it. There's my answer. Y is 6B. Number 4, S equals 40 plus 3t. The equation gives a speed s in miles per hour of a certain car t seconds after it began to accelerate. What is the speed in miles per hour of the car 5 seconds after it began to accelerate? So they really are just testing here your understanding of the word problem and knowing what numbers to plug in where. We are told that S is the speed in miles per hour, and that T is the number of seconds. And then they say, what is the speed in miles per hour? Little side note here. This is somewhere they sometimes get you. They might change, like this was miles per hour, and then they change it to miles per minute or something. But they're being nice on this one. It's miles per hour both times. Just something to keep in mind on SAT problems in general. They do like to do that. So the speed, the rate of speed doesn't change. So they're wanting to know, what is the speed 5 seconds after it began? Again, they're not changing this from seconds to minutes, minutes to hours. They're keeping it seconds. They're being nice. So 5 seconds. I'm going to replace that T with 5, which is what they told me. And then I just do my math here. 40 plus 3 times 5 is 15. 40 plus 15 is 55. That is my speed, 55 miles per hour, and that is D. Okay, number 5. Note, figure not drawn to scale. They do this to prevent you from trying to measure and guess and say, oh, let me see how long. If A is 4 and B is 5, because that's what they're telling us here, then how long does C look to be? So if it's not drawn to scale, don't trust anything you're seeing as far as being accurate measurements. For the right triangle shown, A equals 4. I'm going to write that on my triangle. And B equals 5. Which expression represents the value of C? So they're testing that you know the Pythagorean theorem. The Pythagorean theorem says that if you have a right triangle with sides A, B, and C, then the length of side A squared plus the length of side B squared equals the length of side C, or the hypotenuse, squared. So if I plug these numbers in, 4 and 5, for A and B, and I plug them in over here as well, 4 and 5, what would C be? Now, if you look at our answers, and I do encourage students to always look at the answers before you go into the problem, because you kind of know what target you're shooting for. In this case, they are not asking for a precise value. They're asking for an expression. If it's a precise value, I might go like, oh, okay, so 4 squared is 16 plus 5 squared is 25. Okay, add those together. 41 take square. No, look over here. None of those are going that far. They're not using that square root function on a calculator to get a precise answer. They just want an expression. So I'm at this point, 4 squared plus 5 squared equals C squared. If I wanted to solve for C, I would take the square root of both sides, and that would leave C by itself. And on the other side would be the square root of 4 squared plus 5 squared. And that's D. That's as far as I have to go. I don't actually have to use my calculator for this one. I just have to know what Pythagorean theorem is and then be able to solve for C. Number 6, 4x plus 5 equals 165. What is the solution to the given equation? Another way of answering or asking this question is solve for x. So let's solve for x. 4x plus 5 equals 165. We want to undo everything that's been done to x. So x was multiplied by 4 and then 5 was added to it. We're going to undo those in reverse order. So first I'm going to subtract 5 from both sides to cancel that out. I'm left with 4x on the left and 160 on the right. Then that multiplied by 4, to undo that, I need to divide by 4. So on the left, I just have my x, and 160 divided by 4 is 40. That is my answer. Number 7. The x-intercept of the graph shown is x0. What is the value of x? So this is just testing if you know what the x-intercept is and if you can read a graph. Some of these, honestly, I think because they're more straightforward, they're almost tricky in a way because you're looking for the catch, and there isn't one. The x-intercept is the point where a line, a function, anything that you're graphing, where it crosses the x-axis, and there's our x-axis. As you can see, I'm going to zoom in there. You can see it touches or intercepts the x-axis at a single point. And now we just look at our graph and we notice these are going, that would be 1, 2, 3, 4. They're only numbering the evens, so this would be 7. That's it. At that point, x is 7. That point of interception is 7, 0. So their question of what is the value of x? The value of x is 7. Okay, on to number 8. The function f is defined by f of x equals 1/10 x minus 2. What is the y-intercept of the graph of y equals f of x in the xy plane? A lot of times, man, they use a lot of verbiage there. The y-intercept of the graph of y equals f of x in the xy plane. That's a lot. That's a lot just to say, what is the y-intercept? So let's look at the equation they've given us, 1/10 x minus 2. This is a line. If you just have a single x, not an x squared, an x cubed, anything funky like that, nope, just an x, this is a line. And it is already in the format, what we would call y equals mx plus b, or slope-intercept format. In this format, the number that's by the x, represented here by the letter m, this is your slope. And the number out here, the b that's by itself, this is your y-intercept. So since it's already in that format, if I look at this line, 1/10 would be the slope and -2 would be the y-intercept. I don't have to really do any math per se. I don't have to graph it, nothing like that. I just need to know what slope-intercept form is, and that -2 would be the y-intercept. Now, the other thing they want you to know, because if you look over here, they're putting the answers in ordered pairs where there is an x and a y. So you need to know when you're writing an ordered pair, which comes first, the x or y. X always comes first. It's in alphabetical order. And if you have a y-intercept, it's where it would cross the y-axis, and any of those points where they cross the y-axis. And anywhere on the y-axis, x is equal to 0. So the point here, that y-intercept would be at 0. That's a weird looking, look like a C. 0, -2. That's that y-intercept point. So my answer is B, 0, -2. Number 9. The function f is defined by f of x equals 7x cubed. In the x-plane, the graph of y equals g of x is the result of shifting the graph of y equals f of x down 2 units. Which equation defines function g? Man, they love their verbiage, don't they? So much. So many words for a math test, right? Okay, 7x cubed. I am not drawing this to scale to use their words, but 7x cubed is going to be a cubic. Cubics are ones that go like this, or they can go up and down like that. A 7x cubed is going to be a cubic that goes right through the origin. It's going to be really, really steep, and it's decided it doesn't like my stylus. There we go. Wow. Thanks, Microsoft. I love your products so much. There we go. Okay, so it's going to be very steep. I'm not quite drawing it steep enough. So it's 7x cubed is a steep cubic that's going through the center. Now they're saying there's another function, g of x. And g of x is the result of shifting the graph of y equals f of x down 2 units. So g of x is going to be this whole graph just moved down 2. It's going to look identical, which I clearly am incapable of doing. Let me see if I can select that. Ooh, I can be all fancy. Look at me. Look at there. All right. So there we have it. That would be g of x. So this top one is going to be f of x. And again, I'm not great at drawing these, and this one shifted down 2 would be g of x. Now they're asking, what's the equation for g of x? There's a whole set of rules and patterns that you can memorize for how functions move when you add constants. Those are plain numbers to them. For example, if I have, I'm going to scoot down here, kind of give you a quick run through on this. Because if you have, let's say this is x squared. If I say x squared minus 2, what that does is it moves it down 2 on the y-axis. Okay. If it is inside a parentheses with that x minus 2 squared, if that constant is inside there with the x, it moves it left or right, and it moves it the opposite of what it is. As we just saw with the x squared minus 2, that moved it down 2. It was direct, minus 2 on the y. This one, it's the opposite. So instead of going towards the negative x, it actually goes towards the positive x. So that minus 2 in there is going to move it 2 to the right, and it's going to go up there. So those are the most common. There's a lot of them. There's if you put a number out here, if you put a negative, it flips it. If you put a number that's greater than 1, it makes it more steep. If you put a fraction, it makes it wider. Those are the most common ones that you see. So if I had something, let's say it was like x minus 3 squared plus 1, then I would say, oh, okay, this minus 3, it's moving it on the x, and it's going to move it the opposite. So it goes 1, 2, 3 towards the positive x. And then this plus 1, it moves it directly. It's going to move it up 1. So it would be up here. Same graph, it's just moved over. So those are the principles, and they apply whether it is x squared, x cubed. Like, I'm trying to think of an exception, but the vast majority of the functions that you deal with, this is the pattern you're going to see. I know there's exceptions out there. I'm sure there are. There's always exceptions. But that's what you're most likely to see on this SAT. So here in this case, we have an x cubed or a 7x cubed, and it is moving down 2. So that is a y change. That means it's going to be outside. It's not going to be like an x and then a parentheses thing. That would move it left or right along the x-axis. So it's going to be on the outside. It's moving down 2 or minus 2. So 7x cubed minus 2, or D, is my answer. Now, if you get on the test and you do not remember this, you can just sort of plug and play. You can put numbers in there. So I would look right here, that point 0, 0, and go, okay, if it moves 2 units down, it's going to be at 0, negative 2. So I would look at my answers and go, okay, which one of these, if I plug 0 in for x, will I get negative 2 after I do that math? And again, it's going to get you that answer D. So if I plug in 0 there for x, I will get 7 times 0, or 0 minus 2 is negative 2. D is my answer. Number 10. X plus 7 equals 10 and x plus 7 squared equals y. Which ordered pair x and y is a solution to the given system of equations? So we need to solve for both of them. I'm just going to look at that first equation because it only has one variable, x plus 7 equals 10. So I can solve for x there. I'm going to undo what's been done by subtracting 7 from both sides. So on the left, I'm just left with x, and on the right, I have 10 minus 7, or 3. So I know the first part of my ordered pair is 3, which frankly, I would have known anyway because they gave it to me. Every single answer there has 3 as the x value, so we know we're right on the 3. Next part, x plus 7 squared equals y. Well, we know x is 3. So we put that in there. 3 plus 7 is 10, which they also told us here that x plus 7 is 10. So 10 squared is y. What is 10 squared? 10 squared is 10 times 10, or 100. So y is 100. So I know my answer is 3/100, or A. Number 11. Which expression is equivalent to 7x cubed plus 7x minus, all in parentheses, 6x cubed minus 3x? This is a problem of combining like terms. And the biggest point you have to pay attention to there is that minus sign in the middle. That's the only thing that's really going to trip you up. They have this first part in parentheses. It doesn't really matter that that first part is in parentheses. It definitely matters that this second part is in parentheses, because it's not just saying minus 6x cubed. It's saying minus all of that. For me, the easiest way I find is to change this to a plus and then change the sign of everything inside the parentheses. So I change that minus to a plus. That makes this positive 6x cubed a negative 6x cubed, and makes this minus 3x a positive 3x. That's a good way to make sure you don't mess up anything with that minus. Once you've done that, you can get rid of all the parentheses. That minus was the only thing that made that parentheses necessary. If that had been a plus in the middle, those parentheses would have been pointless. Now that we've changed all our signs, we've gotten rid of that nasty negative or nasty minus, we can combine like terms. And I have two sets of like terms. First, I have the 7x cubed and the negative 6x cubed. 7 minus 6 is 1. So a single x cubed is left. Then 7x plus 3x, 7 plus 3 is 10, 10x. So x cubed plus 10x, or A, is my answer. Number 12, the function p is defined by p of n equals 7n cubed. What is the value of n when p of n is equal to 56? Sometimes function notation can mess with people. I understand completely. I've always been one too, whenever it would get discussed in school, I was always like, but this f of x, why can't you just say y? P of n, g of n, what is this? I know, I get it. But they are saying here, p of n is equal to 56. What is n? So you can just very much straight substitute. When p of n is 56, what is n? That's what they're asking. They're telling you to replace p of n with 56, and then you're going to solve for n. So to solve for n, I need to divide first by 7 to get rid of that 7. 56 divided by 7, I'm going to write it over here on the left, is 8. And 7n cubed divided by 7 gets rid of that 7 and leaves an n cubed. Then I'm going to take the cube root of both sides, and you may know that off the top of your head, or you may need your calculator. It's fine either way because calculators are allowed. On this, if you take the cube root of 8, it is 2. So my answer is A, 2, because 2 times 2 times 2 equals 8. Number 13, I'm going to zoom in on this one. Figure is not drawn to scale. In the figure shown, line C intersects parallel lines S and T. What is the value of X? So they are testing your knowledge of parallel lines and transversals. That's what you would look up if you are trying to find reference on this. And that says when you have these parallel lines, S and T, and you have this line crossing them, a transversal, it creates a whole set of matching and then also supplementary angles. Supplementary means they add up to 180, or they would make a straight line if they were next to each other. So you can see that. So like these two angles right there are supplementary. They make a straight line. These two angles are supplementary. They make a straight line. Just to tell you the flat out rule, if you have this, all these ones I'm highlighting in green, all these angles are the same. Every single time you have parallel lines and a transversal, those angles are going to be the same. And then these angles are all the same as each other. I'm not really going to go into the details as to why that is. That's a topic for another video to really explain the details as to why that is, why we know that's true. But that's the rule they want you to know for this problem. So there's a whole bunch of ones. You'll have like alternate interior angles are congruent. Corresponding angles are congruent. Alternate exterior angles are congruent. There's a whole mess of, things you'll memorize in geometry class related to it. But for this, because you're not having to write a proof, the knowledge you want is that all 4 of these angles are the same and all 4 of these angles are the same. So if this is the same as this, and together these two make a straight line, what would X be? And look at it over here. If this is 110, and that is X, what is X going to be? Together they are 180. So 110 plus X equals 180. I subtract 110 from both sides. X is equal to 70 degrees. Number 14, a list of 10 data values is shown. What is the mean of these data? This is just a straight arithmetic calculator question. The testing here is, do you know the meaning of the word mean? It is another word we use for this is average. When you average numbers, you're going to add all of them together, and then you divide by the number of terms you combined. So if I had 1 plus 2 plus 3 plus 4, I would add those 4 numbers together, which would give me 10. And since I added 4 numbers together, I would divide by 4 to get my average of 2.5. That's what mean means. So in this case, we need to add all of these numbers together, which, depending on your preference, you might do in your head or writing out or the calculator. Doesn't matter. When you add all of those numbers together, you will get 100. Then you count how many numbers you're added. In most cases, here you don't have to because they tell you there's 10 of them. They tell you there's 10 data values, so you don't even have to count them. Since there are 10 numbers, we divide that 100 by 10, and we get 10. That is our mean. Number 15, the equation E of t equals 5 times 1.8 to the power of t. This gives the estimated number of employees at a restaurant where t is the number of years since the restaurant opened. Which of the following is the best interpretation of the number 5 in this context? They're saying interpretation because they're not quite giving you enough information to know for sure, but we can guess. So t is the number of years, and t is that exponential. So we have this 1.8 to the power of t. When we're multiplying something, we see that, the number of years here is to the power. This kind of thing, it's showing an increase or a decrease every year. This, because it's greater than 1, is showing an increase every year. When you're saying here, the estimated number of employees, we can assume that the number of employees would either increase or decrease every year in this context. Seems a little odd, like the restaurant would be growing infinitely, constantly. Hey, it's a math problem. It's not reality, but no, it doesn't make much sense. So here we're assuming that it is growing by 80% is what that 1.8 means. It's growing by 80% every year. They are almost doubling their number of employees every single year. So how would you find, let's say for year 1, if this was like before they started, how many years would they have been open? 0, right? 0 years. So let's look and see what would happen if I said they haven't been open, they just opened the doors. So that would be 0 years. I'm going to replace t with 0. What is 1.8 to the power of 0? Well, all of our numbers to the power of 0 are 1. So it would be 5 times 1 equals 5. So, okay, when it's 0 years since it's open, the store has just opened, I get 5 as my estimated number of employees. All right, so let's look at our options. What would 5 mean? The estimated number of employees when the restaurant opened, the increase in the estimated number of employees each year, the number of years the restaurant has been open, the percent increase in the estimated number of employees each year. Well, we've already eliminated C, the number of years, because they told us T is the number of years. B, the increase in the estimated number. No, that's going to be the base when we go 1.8 to the power of T. That's going to be our estimated increase or decrease. D, the percent increase in the estimated number of employees each year. That's pretty close to B, excuse me. And we're left with A, the estimated number of employees when the restaurant opened, which I'm sure you were already yelling at me. Of course it's A, because we just said we started with 5 when it opened, and there we go. The estimated number when it started was 5. So yes, given what we're seeing here, 5 is the estimated number of employees when the restaurant opened, and it would be increasing 1.8 times every year. You can see that if you replace this with 1 year, it would be 5 times 1.8. So then in year 2, at the end of year 2, they would have 5 times 1.8 or 9 employees. So they started with 5 and they're getting 80% more employees every year because this is apparently an infinite restaurant. Number 16, g of x equals x squared plus 55. What is the minimum value of the given function? The minimum value, they're wanting to know the lowest y value. So x squared, that is just a plain old parabola, and I'm not going to worry about the 55 for a second. If I was graphing x squared, it would look something like this. Forgive my sloppiness. It's going to be a parabola with a vertex at 0, 0. The minimum value there would be 0. The y is 0 at that point. If you were watching this, the whole lengthy video, there was a previous problem that was talking about where I discussed moving functions up, down, left, or right based on this number that's on the outside. So you can go back and rewatch that, or just kind of skip ahead a little bit if you don't want to hear this again. If you have a number that's outside the x squared for a function, it's a plain constant number, this is going to move this function up or down on the y-axis, and it is direct. So a positive 55 is going to move it up 55. So this is going to be way, way, way up here. It's going to be up here somewhere, and this is going to be 0, 55. And that is still going to be the minimum of this function. Nothing else is changing. It's not, the function isn't flipping upside down. There's no negative in front of it. It's just moving up 55. So the minimum value there, the y value is B, 55. Number 17, each year the value of an investment increases by 0.49% of its value the previous year. Which of the following functions best models how the value of the investment changes over time? Decreasing exponential, decreasing linear, increasing exponential, increasing linear. An exponential function is one that it goes up and takes off for the sky. A linear function is a straight, steady rate of increase. And if this was a decreasing exponential, it'd be going like that. If it was a decreasing linear, it'd be going like that. Increasing, it's going up like this. Increasing exponential would be up like this. Increasing linear is like that. Now, they've already told you the value of an investment increases. So right off the bat, those are out. The decreasing ones are out. So now it's increasing by 0.49% of its value the previous year. Anytime you're seeing an increase by a percent over the previous year, that's saying it's increasing by a percentage. It's not increasing by a straight, steady amount. A linear graph is increasing by a steady amount. That's like if I get $5, and then the next year I get $5, next year I get $5, next year I get $5, and I just get $5 every single year. That's a linear function. Exponential is I get twice as much as I had the previous year, then twice as that, and that much, and twice as that much, twice as that much, twice as that much. It's getting boom, 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 bigger and bigger and bigger every single time. So when you have that increases by a percent based on that previous year, you're just adding, and it's a percent increase. This is an exponential function. There's not really a lot of math here. It basically is just knowing what an exponential function is, and that if you're seeing increasing by a percent, it's exponential. Number 18, the population of Greenville increased by 7% from 2015 to 2016. If the 2016 population is K times the 2015 population, what is the value of K? So a lot of this, the 2015, 2016's population, it's a lot of words that don't really mean a lot in the context. The question that they're asking is, if I have a number and then I want to increase that number by 7%, what do I multiply it by? What am I multiplying it by to get to this new number? So to increase something by 7%, look at our answers here. So this represents 7%. This represents 70%. This represents 107%. And this represents 170%. This is one way to look at it. You're saying, okay, so is this new value going to be 7% of the original? Well, 7% is less than a tenth. It's a small portion of the original. No, it's going to be the original and that extra 7%. So it's going to be the original, which is 100%, and then 7% more. It is going to be 107% of the original, which is C. So there's several ways you can look at that. You can just take this knowledge of saying, oh, if I want to get a number and increase it by 7%, I'm actually needing to multiply by 107%. You can, if you're looking at this, immediately go 70% and 170%. Those are out. All right, so if I multiply by 7%, am I getting bigger? No, that's just asking what is 7% of Greenville. If I multiply by 107%, I am going to be increasing that. I'm going to get the final number. I don't have to do any adding later. if this sort of conceptual, general way of looking at it isn't making much sense, and you're on the SAT and you're stuck for time, a good thing I always recommend is start putting some real numbers in there. If you're having problems remembering about percentages or how this relates to each other, or just, the pressure of the test, real numbers are a great way to go. So the way I might do this, if I was trying to remember, oh, is that 7 or is it 107? Like, which one would work? Let me pick some real numbers. So in 2015, let's say there were 100 people and it increased by 7%. So 7% more. What's 7% of 100? So 100 times 7% is 7. So 7 more people came in. Now there's 107 people in 2016. If I multiply by 100 by each of these 4 things, which one gets me to 107? C, 1.07. So that's another way to look at it, especially under the pressure of a test. Sometimes the real numbers can help jog your memory. Number 19, which expression is equivalent to a to the power of 11/12 where a is greater than 0? They're testing your knowledge of exponent rules here. So they have a fractional exponent. How fractional exponents work is like this. If I have 5 to the power of 2/3, it is the same as, I make a little root sign. This 5 goes under here. The 2 becomes the power, and the 3 becomes the root. 5 to the power of 2/3 is the same as the cube root of 5 squared. That pattern, this is how you can switch back and forth. It doesn't matter what numbers they are. It could be 10 to the power of 15 over 72. That would be the 72nd root of 10 to the power of 15. That's what they're wanting you to know. That's the starting point. So let's look at this. A to the power of 11/12. That would be equivalent to a to the power of 11/12. My 12 becomes my root, and the 11 becomes the power. And I go, okay, 12th root of a to the 11th. I've got my answer. Oh my goodness, what's going on? Okay, something strange is happening. This is weird. What's happening? Well, let me look at my answers. I have the 12th root of a to the power of 132, 144th root of a to the power of 132, 121st root of a to the power of 132, and 11th root of a to the power of 132. Well, right off the bat, I'm going to eliminate A and D, because as you can see in these two, both the base and both the root, and the exponent were changed. However, in these two, well, this one, you've got the 11 outside, which I'm just like, no, there's no way that 11 is going to be the root, because I know it's going to be related to 12. And this one, we have that 12th root, but the exponent 132 does not match 11. So already I'm like, okay, these are out. So what am I left with? A to the power of 132, and it's the 144th root of that, or the 121st root of a to the power of 132. So in both cases, I have a to the power of 132 inside. What I'm going to do is I'm going to change both of these into this format, because remember, I can go back and forth. So this first one, B, would be a to the power of 132 over 144. And the second one, C, would be a to the power of 132 over 121. Okay, so, I need to try to get from here to either of these. How can I do this? How can I make these be equivalent? Well, if we have fractions, we can make them bigger or smaller. We can multiply by, in pretty much every situation, we can multiply by the number 1 and not change anything. So for fractions, to multiply the number by the number 1, we would have to multiply by something over itself, 3 over 3 or 15 over 15. Any number over itself here, except for 0, is going to be equal to 1. So I could multiply this times 3 over 3 or 30 over 30, or any number over itself. That would be multiplying that fraction by 1. It wouldn't be changing the meaning. So if I have these two fractions, 132 over 144 and 132 over 121, can I multiply 11 over 12 by something to get to either of those two? Well, let's look at the first one here. 11 over 12. And I wanted to get to 132 over 144. Is there a number that I can multiply over itself to get there? Well, 12 times what equals 144? 144 is 12 squared. 12 times 12. 11 times what equals 132? 12 again. We know our 12 times tables. I know those are the hard ones, but it's good to know them for these sort of things. So, hey, I can multiply 11 by 12 to get 132, and I can multiply 12 by 12 to get to 144. 12 over 12 is 1. There we go. And I go, hey, I think I've got my answer, but just to be sure, because this is an oddball problem, I'm going to check my other answer too. And if you're running short on time, I wouldn't do this, but if you have a second to double check your answer, why not? Let's see, is there any number that I could go, well, this is weird. So 11 times 12 is 132. 12 times, there isn't a whole number that I can multiply 12 by to get 121. 121 is 11 times 11. And that's it. So there's no whole number that I can multiply by, and it's certainly not 12. So that confirms it. That answer is out. That is not my answer A. The power of 132 over 144, which we got from B, is my answer. Yeah, that's a strange question. Number 20, an event planner is planning a party. It costs the event planner a one-time fee of $35 to rent the venue and $10.25 per attendee. The event planner has a budget of $200. What is the greatest number of attendees possible without exceeding the budget? They are testing your ability to make an equation and then to solve for X. So let's read through this word problem one more time and see what we've got going on. She has a one-time fee of $35. So no matter how many people come, the $35 doesn't change. So that is a constant. That's her base fee. And what is she going to add to that fee? $10.25 per attendee. So $10.25 per attendee. I'm going to put A for my attendees to keep it simple. And she has a budget of $200. So she can't go over $200. So it doesn't have to be equal to 200. It could be less than that, but it can't be more. So I'm going to say it has to be less than or equal to $200. Now I just need to solve for A. I'm going to subtract 35 from both sides, and I get 10.25A is less than or equal to 165. Then I'm going to divide both sides by 10.25. And when I type that into my calculator, I get that A is less than or equal to 16.09. So obviously we cannot have 16 and essentially a tenth of a person. So 16 would be the highest number of people she can have without exceeding the budget. Number 21. If the absolute value of 4x minus 4 equals 112, what is the positive value of x minus 1? Honestly, these questions. You'll see why I'm slightly annoyed with them in a minute. So absolute value 4x minus 4 equals 112. If we're solving for x, we would have to look at both versions of it, because absolute value means if I have a number, like say the absolute value of x equaled 10, x could be negative 10 or positive 10 because the absolute value of both of those numbers is 10. Absolute value, what it technically means is how far away is the number from the 0 point, and negative 10 and positive 10 on a number line are both 10 units away from 0. That's what it means. In our our real world application, it basically just means make it positive. So negative 10 becomes positive 10 stays the same. So when you're solving an absolute value equation, you have to take into account both of those options. So 4x minus 4 could equal 112, or 4x minus 4 could equal negative 112. Well, if you look over here, the negative 112, if you want to go through and see it, that's totally fine. When I'm looking at it, my first thought, I'm going, wait a minute. If I add 4 to both sides, this is still going to be negative over here. And if I divide by 4, I'm going to get x is a negative answer. And if I get a negative x and then I subtract 1, it's going to be still negative. So when it's saying what is the positive value of x minus 1, this over here on the right, this whole thing is irrelevant. It doesn't matter. So the only thing that matters is 4x minus 4 equals 112, which also means that this absolute value is just there to mess with you, because this is what they're wanting you to solve. 4x minus 4 equals 112. What is x minus 1? Honestly, it's kind of mean. It really is. Because you're like, the absolute value doesn't mean anything. You immediately get rid of it when they ask you what's the positive value. Anyway, so to solve for this, 4x minus 4 equals the positive 112. I want to undo what's been done to x. First, I'm going to add 4 to both sides. And that gives me 4x is equal to 116. And then I'm going to divide both sides by 4. And when I do that, I get x is equal to 29. But they did not ask me for the value of x. Always, always, always go back and reread your question before you put your final answer in, because they are counting on students to get in the weeds of this and then reach the end and go, x is 29, 29, move on. And they got it wrong. Nope, they did not ask for x. They asked for what is x minus 1. Hard math there, right? So if x is 29, x minus 1 is 28. 28 is my answer. Number 22, a cube has an edge length of 68 inches. Okay. I'm a drawer. I always am going to draw immediately when they start giving me things. So like, okay, 68, it's a cube, so all sides are 68. Okay, got it. A solid sphere with a radius of 34 inches is inside the cube, such that the sphere touches the center of each face of the cube. So like, okay, so there's a sphere inside here, and it has a radius of 34 inches, and they're both in inches, 68 inches, 34 inches. Okay. To the nearest cubic inch, what is the volume of space in the cube not taken up by the sphere? So we're talking about these spaces around it, essentially. It'll be up in this corner too and down in this corner. All these little corner spaces. They're testing your knowledge of volume. Now, if you look at the math, the first page of this module, they do give you the formulas for the volume of a cube. Well, a rectangular prism, but same thing. And in this case, it's the same thing. They're telling you it's length times width times height, which is the same for both rectangular prisms and cubes. And they also give you that the volume of a sphere is 4/3 pi r cubed, which that's kind of nice of them that they're giving you those formulas. So you're going to figure out the volume of the cube, and you're going to subtract the volume of the sphere to find out what that little blue area is. So again, volume of the cube is going to be length times width times height, or side cubed. You might see it represented either way in your math book. In this case, it would be 68 times 68. Wow, that did not write that well. Times 68. Sometimes, and sometimes the stylus stops working. There we go. 68 times 68 times 68 minus the volume of a cube. And as I said, the volume of a cube is 4/3 pi r cubed. And here our radius, they told us that is 34. And that cubed goes with that 34. It does not mean the whole thing cubed. Be careful on that. So now this is big time. This is where your calculator comes in handy. Honestly, I haven't seen a lot of problems on this test that I would think, oh, absolutely, I need a calculator for this. But oh my goodness, yes, would I want a calculator for this one? Absolutely. 68 times 68 times 68 is 314,432. 4/3 pi times 34 cubed. 34 cubed is 39,304. And if I multiply that by 4/3, which you can do quite easily in your calculator, if you don't want to get into parentheses and 4 divided by 3, you can multiply the whole number by 4 and divide what you get by 3. That's a way that's a little easier to do. So we get 52,405 and a third. then multiply that by pi, which is the pi button in your calculator, and you get approximately 164,636.21. Now, if you subtract the 314,000, you subtract that from 314,432, you're going to get 149,795.79, which can be rounded to 149,796. A is our answer. Whew. Thank you, calculator. Number 23, what is the diameter of the circle in the xy plane with equation x minus 5 squared plus y minus 3 squared equals 16? This is a if you know, you know kind of problem, where if you know what the equation of a circle is, it's going to take you 2 seconds. If you don't, you might be struggling with this one. They are testing your knowledge of the standard form of a circle. The standard form looks like this. X minus h squared plus y minus k squared equals r squared. You have, x minus a number squared, y minus a number squared, and you have this number out there. And it's already in that formula. See, you can see there's the x minus a number, y minus a number, and you have the plain number on the side. You don't have to change anything. You don't have to do anything. You just have to have this knowledge that this is the standard equation of a circle, and that this number that's by itself, in this case 16, is the radius squared. So the radius squared is equal to 16. So take the square root of both sides. I would get r equals 4. And if the radius is 4, what is my diameter? It is B8. So again, that's really straightforward if you know that. Otherwise, I think this one's going to be tricky if you don't have that knowledge. So it's just a good thing to know. The reason I drew this is just as a reminder to show you what this actually means. The h and the k in this equation show you where the center of the circle is, and it's the opposite. So x minus 5, it means a positive 5, 1, 2, 3, 4, 5. And this one minus 3 in this case means a positive 3, 1, 2, 3. So the center of the circle would be right there. And this is the radius squared. So the radius is 4. 1, 2, 3, 4. So it's going to be like that. The circle looks something like that, is what that equation represents. Again, just this is something to memorize. Memorize it. It will come in handy. Answer is B8. Number 24. Oh my goodness, this one. I looked at this problem at first and went, what on earth are they asking? And I had to go back and reread it again to really get a handle on it. It's just strange. It's strange. It just is. For the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? Yeah, I don't think this really does a lot of testing your math ability as your ability to kind of just untangle their word web that they have woven. Look at our options here. We're going to start with the answers and work backward is the best way to do this one. Honestly, I think the best way to explain what's going on. Look at all the exponents here first. We'll kind of ignore that 50, 80, 128, 204 point. They don't really matter at this stage. Those could all be 50, honestly. All of them could be 50. All of them could be 80. It wouldn't matter. This is where the key is. X plus 1, x minus 1, x minus 2. Now, if I looked at this, and that's a clue that all 4 of these are different. If some of them were the same, like if this was also x plus 1, or if all of them were x plus 1, that would be your clue that the numbers are what mattered. But no, these are all different. So that's your biggest clue here, that is the key. The 1.6's stay the same, so that doesn't matter. But the x is changing those exponentials. That's going to make a big difference in how these look. So if f of 1 is k, what happens when we put 1 in each of these? Well, here we would have, for our first problem, we would have 50 times 1.6 to the power of 1 plus 1, or 2. For b, we would have 80 times 1.6 to the power of x, which is just 1, so 80 times 1.6. For c, we would have 128 times 1.6 to the power of x minus 1, 1 minus 1, or 0. And the last one, we would get 204.8 times 1.6 to the power of x minus 2, 1 minus 2, or negative 1. Now, what are we going to get if we multiply these all out? 50 times 1.6 squared gives me 128. 80 times 1.6 squared, times 1.6 gives me 128. 1.6 to the power of 0 is just 1, so 128 times 1 gives me 128. I'm sensing a trend here, aren't you? So 204.8 times 1.6 to the power of negative 1 gives you guessed it, 128. Okay. Isn't that interesting? They all give us 128. So what is our question? Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? Now, what was k, the value of k? The value of f of 1 is k. K is saying, what answer do I get when I plug 1 into these equations? So these are k. K is 128 because we get that every single time. So in each of these, k is 128. If I put this number 1 into this equation, I do my math, I get 128 every time. It's like, okay, so I know k is equal to 128. So which one shows k as the coefficient or the base? The base of the exponent is right here, that 1.6. Do any of these show 128 as the base? No. So the coefficient is the number out in front that it's being multiplied by. Which one of these has 128 as its coefficient? Ding, ding, ding. 128 times 1.6 to the power of x minus 1. C is our answer. That's just a weird problem. It just is. 25. A model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. The model estimates that at the end of 2016, there were 180 squirrels in the population. Which of the following equations represents this model, where n is the estimated number of squirrels in the population t years after the end of 2015, and t is less than or equal to 5? There's a lot to unpack here. And when it says a model estimates, this is not talking about, like runway models. This is talking about a mathematical model. Okay, so 2015 to 2020. And they're giving us the number in 2016. It says at the end of 2016, there were 180 squirrels. And also says the population is 150% more than the number of squirrels at the end of the previous year. And we'll look at my options here, because especially with these, with the word problems, I always think it's a good idea to look at your multiple choice answers. If you're having a little problem wrapping your head around what they're asking, it can get you pointed in the right direction. So what do you see? I see 72 is used twice, and the difference here is whether I'm multiplying by 1.5 or 2.5. And then I see 180 used twice, and the difference being multiplying by 1.5 or 2.5. So I'm like, okay. So now I know I either need to figure out if I'm starting with 72 or I'm starting with 180. Because when you have these exponential functions, that's what it is. The number that's the coefficient out there is the base number, the number you're starting with, the number of squirrels in this case that you're starting with. That 1.5 or 2.5 is going to be the increase per year, how much you're multiplying by to get the number of squirrels for the next year. And t is going to be the number of years. For example, if I said I started with 100 squirrels and then it was a 10% increase, so I would multiply by 1.110 or 1. Use that either way. 1.1 or 1.10 means the same thing. So it's a 10% increase because you have the base of 100 and then you're adding 10% more. And then the next year you'd multiply by 1.10 more. And the next year you'd multiply by 1.1 more. So since you are multiplying so many times for so many years, whether you're squaring it, cubing it to the power of 4, etc., That's why that number of years becomes the exponent. It's like, oh, 2 years, I multiplied it twice. I can just write that as to the power of 2. 2 years. That's where this is coming from. So our question we first need to ask is, are we starting at 72 or are we starting at 180? Well, at the end of 2016, there was 180, but they want to know the model that starts at the end of 2015. So even before I've done the math, I know it's not going to be 180 because there were fewer squirrels in 2015. So I know C and D are out. I know that 2015, there were 72 squirrels. Now, they have given you a huge boost right here. They really have. Because sometimes when you look at this percent, like saying it's 150% more, it can be confusing to say, okay, what do I multiply? Do I multiply by 150%, which would be 1.5? Do I need to add 1 to that? What do I need to... It can be tricky and it can trip you up. I get it. So here, by them only giving us the options of 72 or 180, and since we know we're starting in 2015, a year earlier when there were fewer squirrels, we know it can't be 180 as our beginning number. It has to be 72. You don't really have to know how to do the increase by 150%. You don't have to worry about getting that wrong because all you have to do is say 72 times what equals 180. What did they multiply by that first year to get from 72 to 180? So 72 times our unknown, our x, equals 180. We can just divide that in our calculator, and it is 2.5. X is 2.5. So right now, I know my answer is B. I had to multiply by 2.5 to get to 2016. I multiply by 2.5 again to get to 2017. And so honestly, that's the shorthand and the way to confirm that it's right, because they've given you the starting point, essentially, because you know 180 can't be it. So they've told you the starting point is 72. And then you just have to go, okay, what do I multiply 72 by to get to 180? So they're really helping you out with those answers. If this was a question where you didn't have those options there, or if they were a little more varied, the way that you would get this is an increase of 150%. 150% or 1.50, same thing, is being added to that 72. They're not asking you what is 150% of 72. They're saying I started with 72 and then I added 150% of 72. So this is one whole number, and this is 150% of that number. So it is 1 plus 1.5. So that is 100% of the value plus 150% of the value gets you your final value. So each year the total is 250% of the original, or you can say that as 150% more than the original. Again, that can be confusing and it can be easy to get tripped up. That's why I say here, just once you figure out that 72 is the starting and just go, okay, what do I have to multiply to get to 180 is a really quick, simple way using your calculator to confirm it's 2.5. That's my answer, and move on. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.